Well, when I finished up the last video, I forgot to write out this last little piece here, which is that resistance is measured in ohms. That's the unit for resistance, which it says on the graphic over here. You can see it here. I forgot to write that out. Ohms, which is in shorthand, it is the Greek capital letter omega. And so, okay, not going to cover any of this stuff again. That's in the previous video, but I'm going to go ahead and move on right back to this figure that we saw previously. This is a very good figure for describing what the definition of electrical current really is. I'm going to actually move on to the next figure, which is an adaptation of this. So I've drawn a little cross-section here, cross-sectional area. You can just think of this as some area of a conductor. If the charges are flowing through this region, we can take our current with respect to that region. And like I said that current was equal to the amount of charge per unit time. And so in this case, these are all electrons over here on the right-hand side. And so if I wanted to actually, let's say I have, so the elementary charge E of an electron and of a proton is 1.602 times 10 to the minus 19 coulombs. That is the quantity of the charge of one single electron. Okay, so if I say that I have the total number of electrons here is 1 over E electrons, then the total charge that I have would be the number of electrons, which is here, multiplied by the charge of one electron. So that would be, I would have 1 coulomb of charge. And if I want to know how many of those charges have passed in 1 second, then my current would be 1 coulomb over 1 second, which again, like I said previously, would give me 1 amp. Oops, that didn't write very well. 1 amp of current. And so that would be the definition of 1 amp of current. It's literally just if I want to measure how much charge has passed through some window or some cross-section of my conductor in some amount of time, typically per second, then I would take the number of charges multiplied by the charge, and I would find that the current is equal to 1 amp. Again, we're not going to be doing this in this class. We're not going to sit here and compute the number of charges that's crossing through an area. We're just going to see something like 2 amps or 500 milliamps, which would be a half of an amp. And we're just going to know under the surface what that means is that X amount of charge is crossing this portion of my circuit in 1 second or whatever. We're not analyzing things at this level. I just want to give you a good picture of what it means when we talk about current. What is 1 amp? What is 1 amp? This is a good picture of what 1 amp is. It's if we had 1 over E number of electrons crossing through some section of my wire in 1 second. And 1 over E is an enormous number. I mean, you can see that 10 to the minus 19 is the exponent there. 1 over that would be tremendous. So it would be billions and billions and billions. Billions is way too small. I mean, it's a tremendous number of electrons, and that's 1 amp of current. We'll find that 1 amp is actually quite a bit of current. That's a large current. Typically in power systems, you'll see amps of current. We're going to be dealing with things more like milliamps, which would be 10 to the minus 3 amps, or a thousandth of an amp. Sometimes microamps, which is a millionth of an amp, 10 to the minus 6 amps. This would be a milliamp. This would be a microamp. Likely not smaller than that, but if you did want to go smaller, you'd have nanoamps. But I'm going to go ahead and stop this video here, and then in the next one, we'll give the picture for what voltage is.